Good morning, class. This is Mr. Tuttle, and I'd like to go over an example of standard deviation. Standard deviation is the common statistical measure when you have a set of data and you're asking how spread the data is, how close or not so close the data is around its mean. So we're going to take the example from Heiman, page 90. Here are 7 sample data elements. The data elements are 2 through 8, which I have graphed. So the first one is a height of 2, the second is a height of 3, and so on. And we want to know what is the standard deviation of this data around its mean. So the first thing we do is add them up. The sum is 35. If we count, there are 7 data items. It's 2 through 8. There's no 1. There's 7 data items. So if we divide 35 by 7, we get 5, and that is the mean. I've now filled in the remaining numbers because it would take too much time to do them slowly. But the first thing we do is ask, what is the deviation of each item from its mean? So the first data item is 2, the mean is 5, 2 minus 5 is negative 3, 3 minus 5 is negative 2, and so on. And so these are the individual deviations from the mean. And in fact, I've graphed the 7 original data items. I've graphed a straight line of the mean of 5. And then these black arrows indicate the deviation from the mean. So the first data item, which has a height of 2, it is negative 3 away from the mean. The second data item, which is 3, its deviation is negative 2 from the mean. So these lines indicate the deviation. There are some positive, some negative. If we add them all up, we find 0. So if we were to say the average deviation is 0 divided by 7, well, that's not too helpful. And the difficulty is that the negatives and the positives cancel each other out. So we need a different way to do this. And what mathematicians have chosen to do is take these deviations and square them, and that will get rid of the negatives. So negative 3 squared is 9, negative 2 squared is 4, and so on. When we have these square deviations and add them, their sum is 28. 28 divided by 7 is 4. But now, since we squared these deviations, we really want an unsquared number. To get rid of the square, we take the square root. The square root of 4 is 2. And 2 is now the answer to the question, what is the sample standard deviation of these numbers? It's 2. So on average, these numbers deviate by about a factor of 2 around its mean. And while this is the end of the answer on page 91, Heiman does give us 2 different formulas for standard deviation, and they differ in that one is a capital S and has a denominator of n, and one is a lowercase s and has a denominator of n minus 1. The one we just did was the capital S with a denominator of n, and that's the sample standard deviation we use for descriptive purposes to describe the data. Later on, in fact on page 96, we will see that there's a slightly different formula which will be used for inferential purposes, which also means for estimating the population standard deviation. And there we use a denominator n minus 1. So n was 7, n minus 1 is 6. If we take the 28 and divide by 6, we get 4.67. Its square root is 2.16. And 2.16 is the standard deviation we will use with the lowercase s later on when our interest is estimating the population standard deviation.